for everyone, or not so unfortunate. The shakuhachi is an instrument where if you want to build it yourself, you can be an expert at using tools, and you can be an expert at carpentry and fine woodworking, working on the lathe and a whole bunch of different things. You can put in the mouthpiece. You can do all this kind of stuff. But to resonance tune your flute, you have to be able to play it. I had a friend who called me up, a fellow maker, and he said, "John, I was playing on a flute this morning, and it was working really good. And in the afternoon, it wasn't working anymore." And I said, "Well, what did you have for lunch?" And he said, "Oh, I had curry rice." I go, "Oh, no, curry rice, you can't. Don't do curry rice. It's never going to be, shakuhachi's never going to work." But it was totally joking, of course. But the fact is that if you have a full stomach, or if you eat a lot of salty, spicy food, the mouth can get dry and you're not in prime condition. When I work on a flute for 5 minutes, it takes me an hour and 5 minutes because I'm going to practice for an hour before I even look at it. So I don't know about you, but when you do something to a flute and when you check it, you want to make sure that it's the flute that is performing as you think and not you. And so I don't try to make everything sound perfect. I play naturally. And I have a sense, because I've worked on so many flutes, that okay, this is acceptable and this is not working yet. Let's see if we can fix that. So we're going to go through some basic acoustics of the flute first, and then we're going to look at this chart and we're going to do some hands-on stuff. We passed out some water, and we're going to wad up a wet piece of paper, and we're going to put it inside the bore in certain places, and we're going to see what it does to the flute. And I'm going to do a demonstration that I do every time I do a workshop like this, and every time I'm hoping that it will still work. You can see the amount of material that I have on my finger. If I put this in the wrong place in my flute, it totally does not work. And I'll demonstrate that for you. And even now, I'm just like, "Guy, this is unbelievable. Maybe it won't work today, And I'm worried that it won't work because this is almost nothing. In fact, I wet it, and it's going to be hard to even put it in the bore and then see it. Now, if you work on a flute, it's obvious that you should be in a place where you have a nice bright light. We don't have anything here, but for instance, if this was a light and coming out and you turned it on and you had this nice bright light, something that you could look into, a desk lamp would be fine. You could do like that. And outside, when there's sun outside, you can look up that. I think you have to do with the lights up above when you're looking, when you're even putting the paper in with your free chopstick. What's the sound of one hand clapping? Well, maybe this is the sound of one hand eating, or one chopstick eating. You might try it, especially if you want to go on a diet. Now, first of all, most of us are familiar with a string. Oh man, how come this is not working? A string you can see, and when you pluck it, it goes back and forth. And since you can't see the air that's moving, you wonder, well, what does this have to do with it? But the same kind of idea of a string is applicable to the wind. Inside, it's the wind column that gives you the resonance. In fact, when you make a shakuhachi, and you have holes, okay, so it's the same kind of movement, but what happens with the air? you don't think of air as being a spring, but it actually is very springy. It's flexible. And so you send an air column down into the flute, any open-ended flute, and it bunches up. In fact, it bunches up so much that the pressure becomes higher than the relative pressure on the inside of the flute, which of course is different than in this room, and the pressure in here is different from the outside. But that's another point. In any case, the air bunches up until it springs back. And then when you're blowing, you're pretty much splitting the sharp edge between going in and going out. And when it backs up, it kind of shoots your airstream slightly out. And then when it goes back down, there's kind of a minus pressure, and it helps to bring the breath back in. And so this going in and out is augmented by the bore itself. Especially when it's a conical bore, then it's gonna, you know, if you have a tube of toothpaste and you squeeze it, well, there's how much pressure? Well, if you have a big hole, or if it's quite close, well, a lot of it's gonna come out. Then further down, it's gonna take a little more energy for the same amount to go, and it also depends on the size of the bore and the size of the hole. If you have a small hole and a big bore, you're going to have more impedance. It's harder for it to go out. So for instance, on my flutes, one of the things that are different is that the holes are large. I like 5 holes, and we won't go into exactly why I do, but it makes my compositions more interesting, I believe, rather than a total chromatic scale. Now, you notice on my 1.6, the holes are fairly big, but they aren't as big as this. And I didn't bring my 2.4, but they're even bigger on the 2.4. The reason being that they don't need to be bigger than this on the 1.6. And you notice that the lowest hole is the largest hole on my 1.8. This is because it has the most impedance. The further you go, the more difficult it is for the air to resonate and come out. And the closer you get, like the back hole is pretty standard size. But all of the others, and in terms of pitch, of course, this is an old flute that I remade, and the original holes were here and here. Look at how far that the G hole went down. It's where my finger is, here, and then here. And I actually, over a period of about a year and a half, I moved the holes 12 times, literally. I would fill it in, I would carve it out so that it was in tune, and I would play on it for a month. And then I would fill it in, the whole hole, and I'd move it down lower, and I'd make the hole bigger. Now you notice that my holes aren't round. Well, that's because I can't cover a hole that's perfectly round with this size. But I can if it's in the direction of where my fingers are. And so I literally took the bamboo and I drew the mark around my finger and then opened up the hole with a knife, because you don't have a drill that opens up like this. So we'll get into that, but let's go back to the basic movement of the air. So it's moving down here, and then whatever the length of the flute, if you have all the holes closed, of course, then your resonating tube is this long. But when you have the first hole open, well, the actual wave goes a little bit below, but also the wave is also a little bit below. Here, the air is going in and out of this, which is unlike a reed or a trumpet instrument, mouthpiece instrument. So both of these acoustically, the hole, this hole, and all of these holes are acoustically fairly similar because the air is going like this. So for instance, a hole that you have on the inside of a flute, you know, when you drill it, oh, you want to be an expert, right? It's a nice clean hole with sharp edges on the top and sharp edges on the bottom. That's no good. If you think of water and air as being the same, and then you get the right idea. Everything should be Now, of course, that affects the pitch. So you have to open it up a little bit lower to get the right pitch. But this is how a water pipe would work better. And even this, it's going in and out, so I don't like a sharp hole there. I round it out just a little bit. When you first cut it, it's almost sharp enough to cut your finger when you first drill it. But here I've also rounded it out just slightly. Not much. You've got to be able to feel it because the half holing is difficult and whatnot. And you have to be able to seal a hole or you're going to be in trouble, as you know. But the inside, you can just see, it's the air that's resonating and it's the air that's going. And not only does it resonate from there, but it goes to here. It's really flexible stuff. So that means it's also coming from here a little bit when it's going in and out. Well, that means that this, even though the pressure points point to the half or the half of the half for the first two fundamentals, even though it's not there, the choke point, which is right around this hole should be physically down below, but maybe about halfway or a little bit further up, it's going to be in this area for the smallest point. Now on a 1/8, you start with about 20 to 21 millimeters, and then it gradually, but not symmetrically necessarily, to the choke point that's about 15.6 or so. And then the lower hole, depending on if it's 1.8, if you put a very big hole on it, it's going to be too high. So I lengthen my flute so I can have a slightly bigger hole. You might wonder why a trumpet has a bell like this. It's so that the high overtones escape a little easier, apparently. And it's true with a Western flute too. A shakuhachi as well. So we have the air that goes down and it compresses. It has to go down and come back one time, just as a string has to go up and down one time before you will get a pitch. So it needs to make one cycle. That's why when you play a long flute and you blow into it, the response is slow. And then if you play on a little short flute, pop, and already the sound is there. It's like a bass player going boom, and it's kind of like just a slight delay because it takes longer for the string to go back and forth. Whereas if you pluck a violin string, well, it's only this long, it goes boom, and it's immediate. I was in Bali, and I don't know if you know about the Jagog tradition, but there's an all bamboo band, and there's these big long bass tubes that half of it's open and half of it's a resonating tube, and they actually sit on top of it with a mallet that's about this big, and they go boom, boom, dig this. And what's really cool, I was at a bamboo festival, and it was in this big, huge open area, and when you're about 50 meters away, you can see them going, and the sound goes, for the bass, but all the high tones even reach you much faster. So the bass was delayed noticeably. Now, in a concert setting, you don't find that so much, but even in a jazz group, Western bass player, if they're playing acoustic bass, they know that they need to anticipate it just slightly because their instrument is a little bit slower. And so they don't even think about it. It's just the way you do it. But it was amazing to see this guy going boom with this big mallet, but then all the other notes are already reached me, and it's like, it was like a half a second or almost a second delay. So in any case, a shorter flute is easier. Now, there's a couple of things that's really basic, but we can also talk about the strings. Again, you don't use a bass string and expect it to work really well on a violin, right? Or you don't take a cello string and you don't take a cello and expect a violin string to work. Now, a thin one, meaning a small bore, for instance, a small shakuhachi, thin, you're going to get the high octave to work pretty well, but the low octave won't work. Or a big bore, maybe the low notes will work for you, but the high octave is not going to work. Now, to get everything to work, this is not my research that gave me this information. It's a guy that did a side-blown flute, but with really large bore flutes. And I found that this is like a kind of rough estimate. On the inside, you can go approximately 28 to, this is the length, to diameter. Okay, you can go, you have a little bit of flexibility, 21 to maybe 31. 28 to 31. Now, maybe you can go slightly plus or minus, but this overall length versus diameter is a good starting point. So if you measure the inside of your 1/8, and of course, again, it's not this, it's a conical bore. It's getting smaller as you go down. You know, it's not as radical as this. And then after the choke point, it flares a little bit and not as radical as this. But this is the idea with the... So then if you took an average of 15 and 20, if it's a straight bore, then kind of the average would be less than 20, which is one reason why the water pipe that you might experiment with to make a flute doesn't work so great for a 1/8 actually. If you have a nice bamboo mouthpiece especially, it's really cool to change mouthpieces to get a good idea of what's happening in terms of the length. But if you know, a Western flute is just about 20 millimeters, which is the standard plastic PVC water pipe on the inside. Okay, so this actually works a little bit better for a 2.0 or a 2.1. This is just how delicate it is. So in any case, if you look at the chart that I made, what happens is there's a series of overtones. This string does not vibrate completely symmetrically. You are also going to hear half of the half, and in thirds as well. This is like the third overtone. Half of the half would be more, well, this is not the length of the flute, but if you have here a length of the flute, and then you divide it in half, this is pretty much the halfway point, and you have to go, if you're measuring from the hole, you have to measure a little bit lower than the hole, because the wave doesn't just stop there. But you only have to measure a little, because actually here, the wave doesn't stop here either. So when I measure for a hole, for instance, and I was gonna do work on a flute, and in fact, if you have a pencil and you have your flute, you're welcome to borrow this. And if you have a problem on the flute, anyway, I would measure from about this area, so that the high octave or the low octave, the ha or the kinko ri, would be approximately 28, not right in the middle of the hole, but a little bit below it. And then you'll get the right kind of measurements. Now, the fundamental is pretty much half of that place. And then the first overtone, which is extremely important on the shakuhachi, when you play one note, you're actually hearing, like if you play otsu no ro and a low octave ro, then you're hearing the kano ro, and you're hearing the third, you're hearing a chi up in there, and you're hearing a fourth overtone. So all of those provide it with a really rich sound. And depending on how those overtones sing out, you can immediately tell the difference between a violin or a trumpet or this. Also the noise that comes from the string and other instances, Or for instance, a clarinet is a little noisy with the breath escaping and stuff. So there are other things, but it's the overtones that give you the distinctive sound. Now, I have been accused of being kind of sacrilegious in a way, but in all of my studies and in all of my experience, I'm sorry to say, it's not the sound of the bamboo, but it is thanks to the bamboo that we can make a shape like this. So I don't say 100% that this is not the tone color of this, but this is the sound of bamboo. This is the sound of the air column. Now, some of you have played on the metal flute. Well, I have flutes made out of glass. I have flutes made out of ceramic. Somebody commissioned me to make a flute out of rock. And so, you know, Shakuhachi, you know. So you might wonder what it sounds like. Well, it was really hard to tune it. And it smelled like a dentist office. And it took me, you know, like 45 minutes just to change the pitch a little bit. And it was terrible to work with, right? But nevertheless, it's the air column that's vibrating. Think about it. You have two hands and you have a death grip on this instrument. How do you expect it to resonate? If you had two hands on a marimba key, if you had two hands on a vibraphone key and you hit it, would you expect it to vibrate? Well, yeah, you could feel it in your hands, and yeah, you can feel it in the instrument. But I'm sorry to say that I am happy to say that there are characteristics of Madake bamboo, the size and the thickness. If you don't have this thick of a wall, you cannot make this mouthpiece. And if you can't make this mouthpiece, you can't have the Shakuhachi sound. So it is because of the bamboo, the shape of the bamboo, but it's not the material that's resonating. So I don't want to, you know, you don't have to believe me, but every single thing that was done in terms of research, when the Western flute, they went from wood to metal, there's a huge backlash. Nobody wanted to believe that, you know, the nice wood sound, you know, the wood instrument would ever be able to be copied by a metal instrument. So they did all these studies. They, behind the screen, composers, other flute musicians, the general public, they did all of these tests, and nobody could tell the difference between metal and wood. So I hear some people say, well, yeah, denser, heavier bamboo is going to give you a better sound. Well, the fact of the matter is, it's not the heavy, denser bamboo that's giving you the resonance, it's the shape of the air column. And that's one of the first things you'll learn about wind instrument. Yeah?
Sorry, that's always for flutes with G, like G-ari.
No, we're talking about any flute.
So
And made out of anything, it's the air column that's vibrating. It's not the material.
So if someone were to say that they hear a difference between a jinashi flute and a plastic flute of the same, then what would that, you're saying that that's...
Okay, what it is the air column is not the same.
Okay.
So what I'm saying is that if you could duplicate this completely, and I'm talking about everything, and I'm going to demonstrate right now how delicate it is, but if you could duplicate this completely in plastic, or metal, or in glass, you would not be able to tell the difference in the sound. Yeah. But that is amazingly complex, and that's what we want to talk about, is the shape of that bore. Now, not to discourage you, but to make it interesting, you know, I was talking about, okay, I'm going to demonstrate on my flute. You know, we might as well just do it now. I need a little water. So, okay, so how about this? Oh man, if it doesn't work, I'm going to be embarrassed. And I think that every time, and it does work. So look at the mouth. And what I'm going to do, look at the chart and look at the kanno ro point. There's two of them. I'm going to put this in the smaller one in the, チャートは 見てください。ごめんなさい、英語ばかりで。今がそういう細かいのポイントが、これじゃなくて、プレッシャーポイント。もう一枚、ないですから、printed. None. Okay. This is what it looks like this. Okay, yeah. 後で、取ってください。そして、缶のローのポイント。So check it out. You don't have the printouts for this? Oh, looking at it right there. Okay. So where is the Kanno point? The bottom one. You can see it's between the first two holes. Now, I'm sorry to say that that is slightly inaccurate. I find that it's actually a little bit closer to the lowest hole. So that's experience. This I just divided everything by half, and then I did the half of the half. But I wasn't compensating for the fact that it's a tapered bore, is why I believe. Okay, now, so I'm going to drop this in here. Okay, well, first we're going to play. Okay, this is what it sounds like. This much I'm going to put just above the first hole, if I can get it off of my finger. And I'm going to use, I use stuff like this for longer flutes and stuff like this for shorter flutes. Okay, now it's sitting in the bore, and I can see it. There's this little piece of paper, and you're welcome to take a look later on. But what I want to do is tap it down so that it's level with the bore, and I'm going to move it forward just a little bit, okay? So right now, you can't see it through the hole because it's just above. It's right about in this area here. And watch what happens to Kanno Ro. I'm going to blow exactly like I just did. It doesn't play. I'm not playing any different. Okay, watch what happens to the low octave. I call that the $1 million vibrato. And then listen to the top octave again. So I'll bet every one of you is good enough to tell the difference on this flute with that amount of change. But we're going to get very, very subtle in some instances. Now, if you look at the chart, you'll see that where is the low octave row? Just tell me about in terms of where the holes are. Where is the low octave row? Point, pressure point.
The fourth hole.
Yeah, the fourth hole. Yeah. So it's just below the fourth hole. But show me where the high octave chi point is. Look on the chart sideways.
Ah, same place.
The same place. So let's say we have a flute, and this is what this interesting bore. I mentioned this particular idea. So let's say we have a flute that's not working, but the chi in the low octave is, for some reason, it's fluttering. Okay? So maybe we can put it here, but the first place that we have to look as a very important part is the most important note, the fundamental. We have to see what's going to happen there. So this is a way to check other points to see what it might become a problem very quickly. And there's two ways you can fix something. You can make something smaller, or you can make the relative other points bigger. So let's say that you don't like how the row is playing. Quite often, the low octave row, quite often by filling in here and making the high octave row play bigger and brighter by putting something in here, will fix this. But you have to check. I can't tell you, you know, sometimes there's a characteristic, and so chi as well. The problem is chi. So if you want to fix the chi, and let's say it's the high octave that's not working, okay, you put something in here and row becomes terrible. Well, what do? Well, then maybe instead of adding something, you have to subtract for the low octave chi, because when you play the high octave, it wants to drop this point down here. If you look where the low octave chi is, this one, maybe it has a little bit of room that it'll be okay if you decrease the pressure for the low octave chi. The high octave will start to sing, and in fact, most often the low octave chi will even play better, because when the high octave chi has too much pressure here, then you know, the low octave chi is not. It's all relative, every single thing. So it's like this puzzle, you know. And I say relative and puzzle. You know, I'm not Einstein, but it's pretty amazing that, you know, he talks about relatives a lot. So. But in any case, yeah, you have a question.
What you're adjusting is the hole, but not on the inside? Or are you talking
No,
about
I'm talking about the inside bore.
Oh, okay.
Yeah, the hole, but see, how I was aware of all these things was the first thing that I did, I tuned my flutes. And it changed the way they played. So I immediately knew that it was really sensitive, that even a small carving to bring something up or filling in a little bit changed the way it played. But I had no idea that it was as complex as this chart is until, so I might as well just tell you. There's the high octave of the tsu is notoriously difficult. It's just hard to play. That's an overtone of the B flat that I'm pulling it like that. Some people are going like this. They half hole with the leg. But you know, you jam your flute, you jam your face. That's not working very well for me. So this was really difficult. But this works, the B flat, the Ha meri, or the D meri, O meri, is the fingering that the overtone would be that F sound. And so if you open up here, you can get a bigger hole, and sometimes it works on a 7-hole flute. You get a very nice high F. And so I opened the hole, not for the Ha meri, I opened up the hole for the high F only. It still didn't work, but I noticed that the low octave re played better. Okay, here's the low octave re. I didn't do anything with the low octave re. Why is it playing better? And this is a secret. There's still a hole underneath this. I covered it up, but there's still a hole in my flute because it plays better. Okay, but anyway, so why did that work? Well, what I figured out was that half of the half, it turned out that the hole was right at the high octave re, and this made it a little bit weaker, but it still was plenty strong, and I could sit on the low octave re with a lot more power and not have it pop into the high octave, and I realized that I could equate size with how much pressure or how much inclination for that note to be really bright or strong, and size of the bore at those pressure points. So it doesn't always work, and the whole, like even the choke point will affect, even when you have all the fingers open. This area, everything affects everything. But the chart would be the first place you would look. I have a folk music professional who orders from somebody else, and they put in a hole here and a hole here because he likes to play on 7-hole flutes. It's convenient for him. And then the flute doesn't play. He orders the flute, put the 7 holes in there, and the flute doesn't play. And now why the maker doesn't have a hint that maybe if he filled in a little bit below the hole, that he could fix it? But he says, oh, I can't fix it, I don't know how. So the guy sends it to me, and usually it takes me 10 minutes, and I charge him $100.
Not enough.
Yeah, it's not enough. Yeah, he's getting 30 years for free, so it's a good deal. Yeah, yeah. So the fact is, you can see how delicate it is. You know, I'll try again. Kanuro just does not play. It immediately gets too bright and disappears. I can play it soft. And you hear Otsunoro, no problem. But I don't play like that. I want to play. And if I back off, so that's the power I could play with. But if I want a diminuendo, right in between it, jump to the high octave, and that's not where I wanted to go. So it's really delicate. But right now, we should open it up, I mean, because it's going to get even more complex as we go. But do you have any other questions? Well, yeah, go.
For materials of flutes, when
Yeah.
you're in different temperature conditions,
Yeah.
do you know how how a metal flute compares to like a bamboo one? Or
Exactly. This is very important. The temperature, the overall ambient temperature, totally radically affects how sharp or flat a flute, a wind instrument plays. So it works for all wind instruments. Western flute, metal, shakuhachi as well. So I actually made a flute that had an adjustment point. And of course, when you lengthen it, I had little rings that would fill in there. And it was a real bothersome, and I ended up just epoxying it together because it was too much trouble. Now the shakuhachi is really hard. If you have a flute that's too high, you can lengthen it. And so, for instance, my flutes are a little bit longer. This is the 1/8, it ends here. This has been added on afterwards. I could not only make the hole a little bit bigger, so I had a brighter sound, but the pitch was better. I was playing too high to play with Western instruments. So, since it's a solo instrument, and you normally, the real traditional stuff, you never played an ensemble. It's only since Meiji, it's a little over, it's not even 200 years old that it played with koto even. And for koto, it's a string instrument, so they can tune up.
And because I'm in marching band, so like clarinets and other instruments.
Oh yeah, everybody, yeah. So what you do, you form a shakuhachi marching band, and then you don't have to play in Western pitch. Actually, I've heard of a 4th of July parade in Willits, California, where my friend Monty Levinson lives. And during one of the big parades, there was a whole group of about 10, 12 hippies back in the day, early 70s, that they wanted to march in the Willits Willits parade. So I would have loved to have seen that. So yes.
John, I have a question.
Yeah.
I play lots of contemporary music, and I use always 7 holes. Why, when you drill the hole of Ha Nomeri, why in some shakuhachis you can get very easy the 2 daikans, and in others it's like, and it still doesn't come out?
Okay. So the acoustics are very difficult. And in my case, I put in quite a big hole here, and I still couldn't get that overtone to work. And yet I have another flute that just played beautifully without putting a hole in there, with using the half hole up above that. Now the 7-hole flute has the advantage that you have the same pitch, but it's a larger hole, so that note would more likely vent, which is why I put it in there. I wanted that high F to sing for me, and I didn't get it to work. But then I got another flute that I used only when that high F was important, and I like the way this plays overall better. And so I avoid that high F. You know, I don't hardly ever. If you go from it from below and it's short, then you don't really notice how bad it is. But if you go, you could use it in a phrase like that. It's not too obnoxious, but I don't use it hardly ever. Yeah. So, and it's because the rest of the acoustics, you know, the rest, you know, even when you have the 7-hole flute, some flutes work and some don't. It's very subtle when you get into the 3rd octave. Yeah.
I noticed that.
Yeah.
Because, one of my teacher, Professor Fuda, he said that the whole of Hanameri should be like 7.5 millimeters as average diameter. And in some of the scores I play, we have certain phrases that are quite fast. I'm playing different notes in Daikan. One word appears to Daikan. So sometimes I feel frustrated because in some because
It works and some it doesn't.
In the other ones, I
Yeah.
like,
Now, so this is a problem, and it's also a great thing. For instance, every single person has a different voice, right? And especially if they sang one note and added some vibrato, or if they added some feeling to the note, you could tell exactly who it is. And when I was studying seriously Shakuhachi when I first went to Japan, and listening to a lot of recordings, I could tell with one note if it was Aoki Reibo, or if it was Yamaguchi Goro, or if it was Yamamoto Hozan, or Ikeda Seizan, or you know, whoever it was, I could tell you with one note who was playing.
yeah.
And then if you have a couple of phrases, it's the same. But you could do that with a vocalist as well, right? So somebody that you're familiar with their voice. Each individual flute, each individual person has a different sound and a different voice. And that is actually a really good thing. So, you know, your flute might not be perfect, but neither are any of us. And so you do the best you can with it. And if you have a specific problem, you like this flute, all except for this one note, maybe during this class we can even, I gotta see what the time is, it's already, okay, see, we're already running out of time. But the pressure point chart does not tell you where to make it bigger or smaller, it's just the first place to look. And so what I want to do now is to have you, all of you, take a piece of paper, and maybe even just half of what you have there, wad it up so that it's in, you know, something about this size, and let's put it in the same point that I did. So it's like this, it's going to stick to the wall, and we're going to put it into the row point from the bottom. And if you don't want to do that, you know, if you just had some urishi done, you have to trust me. Or, I'll tell you what, you can do it on my 1/6. What was it? Oh, it wasn't you. I'm sorry. Okay, so if you want to try, first play on it so that you're familiar with how it plays. And then when you put it in, then check it out. So you should have some chopsticks.
I don't know if we got questions.
Were there not enough chopsticks for everybody?
You can share.
Oh, okay.
You can share.
Yeah, here's the guy that you up and said it to do that. Besides, you have a Shakuhachi maker next to you. He can help. So, do something like this. First see how it plays for you. And then see if you can tell the difference after you put that in. Right about here. Right about between the two balls. Okay, now you might want get familiar with your kanoro. This is the kanoro point. Do you have some water and a
I'm just gonna
chopstick?
borrow somebody else's if I could.
Okay, yeah. Why don't you come over here? This guy can help you.
Okay.
Yeah, just take your flute. Yeah, you can. Fold it. You can wet it and then fold it. Yeah, you don't need any trouble. But there's lots of newspaper stuff. It's nice when it's flat, like this. Yeah, that's fine. And then you can drop it through the hole and then push it down on the floor. It'll look on the inside. It'll be way more dramatic maybe something about this side. It might not be able to tell. And if you do this side, that's a little bit more natural. You can just go like this. No, it can be anywhere, it just has to be flat. And so it's easier to see on the bottom. And so you can start patting it down without really looking at it, and then take a look at it. It needs to be patted down better. So get it so it's flat. No, it's already did. Yeah. Okay, now use the other end. Yeah. So you need to make it flat. So that it's not obstructing things, that it's changing. Yeah. Did you try it?
I already know that my re is flat, but that's like a row on a 1.8.
Right.
Can I put it
Okay, it's flat in terms of pitch.
here?
Okay, that's more, undercut the hole bigger, but then you would have to watch out. For instance, you're talking about this note here, right? Here, okay? Yeah, okay. So, then, if you make this slightly bigger, for the hole, then you have to worry about kannochi, and the most important one is the otsugogo. That if it gets the roll is going to get bad, so before you open it up, be sure you know how the roll plays, and then if the roll gets bad after the pitch gets okay, well then see how much little amount of putty or something that you would need to add at that point.
Something like this was already fairly big.
Yeah.
Can I undercut it?
It's good to undercut it.
I mean, I do anyway.
The more you undercut it, you gotta think of water. It's gonna flow better. This is the hole. It should look like this, not a nice straight cut.
Can you undercut it so it's almost up to the surface? I mean, really?
Yeah. And all the way around.
Yeah, because the wall is pretty thick.
Yeah. I work on flutes that are like this, and it's like this that I've undercut it. Almost sharp. That sounds like shit. Yeah. And without very much, right?
Yeah.
So then see if you can do the Neptune trick. Okay, so if you go over here, this guy, we're gonna use him as an example. He says on this flute, and if you don't mind, I'm gonna double check that. Not that I don't believe you,
No.
but he says he doesn't like,
Probably the player anyway.
well, no doubt it's somewhat that way. He said that he finds that the chi is difficult. I said the higher the low octave, which one? And he says both.
Both, but the lower one maybe more.
Okay. Okay, so when I play it, you know, and I have experience, the low sounds fine to me. And but listen to the high octave, I can play re like this. And now what? Let me play the same way on the chi. Can't handle that power.
I think it's
Listen
the
to
high
this.
one after all.
See, I immediately think, oh, the low octave is okay, the high octave is not so great. Let's see if we put in something here, and it looks like, did somebody work on this a little bit?
A little bit, yeah.
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 It looks like maybe for the pitch, they opened it up, and that's right where the chi point is. And also, this could be, it could be leaking. So you get some plastic tape, which did I bring with me? Get any kind of tape.
You probably
So
recognize it.
if it leaks a little bit, it could sound about like that, and that could be the problem. So then you wouldn't have to do anything to the board. But let's check that out. Oh, can you just give me a little piece that I could wrap around the not the soup? Oh, you're talking about plumber's tape for the inside. Well, I think it'll work. It'll work. Yeah, I would like it on the outside.
Oh, on the outside.
It should work. Yeah, so you're talking about Wakatsuki. So,
Inside.
I use plumber tape.
sorry. Okay, this is for working on the inside of the flute, so the tape, but let me see. Okay, so that's not it. So let's check. Can we maybe improve? Now, we want to improve the con chi. So take a look at the chart. Where is the high octave chi? There's 2 points. And because I'm looking at this, somebody has raised the pitch a little bit, so the hole is undercut. That's good for the pitch and it's good for the sound, but maybe not good for the high octave chi. So let's try putting in this much right here. And we're going to pat it down with this. Let's see if we can get this better. Okay, you saw the amount that I put in there, and it's just right where it looks like it's undercut. Wow, that sounds like it's ringing better too. So that's no problem with the row, which you would want to check because it's close. It might be we could try just a little bit more. But it's better. Oh, sorry. But this is the kind of stuff you got to do: is define the exact point and how much. Let's see what we got here. Another thing is, you know, like if it takes you 5 minutes to put a piece of paper in, and I'm exaggerating, even if it takes you like 30 seconds or 40 seconds, that's not good. It should be immediate because you don't want to forget how you played. Exactly. leak, I might want to look at the low octave chi point rather than keep adding more and more here. But you test it and see if you think it's different. This is still, it's a little bit, that's not good. I'm not sure how you fix it. Maybe you take some of this stuff, you ask him, he's probably the expert on this is, you know, for getting water pipe not to leak, right? You put it in the threads. Oh, what's it called?
Teflon.
Okay, yeah, I'm losing my English, but yeah. So that might work for here, but here, have a tune on the high octave chi and see if it's better. Okay, now, yeah, you can't tell, but now we're gonna take it out and you're gonna try to play just like you did and see if you can tell the difference. Now, see, this is a case in point. You might not have the chops to be able to decide real quickly. And that's the thing. I can't emphasize enough. Just become the best player you can, and then you'll be able to tune your own flute. Otherwise, come ask me.
I'll ask you for a while.
Okay, so I don't know if you can tell the difference. It sounded even weaker than it sounded before. And so, I mean, we're moving in the right direction, but it actually may be that the low octave is even a little bit too powerful, and that is messing up this overtone. So what I would do from now, I would put in very small amount, just like I put in like this, and then if the high chi gets even really worse, then okay, here's an instance where I would shave the low octave chi point to get the balance between the high and the low octave happening. The re is working, the ha is working, or the di is working in both octaves, so the chi is the one that you would want to focus on. So you were correct in your analysis of what the problem was, that's it, but then how to fix it is maybe a serious, until you have more experience playing.
Right,
Yeah.
right.
And I don't know, could you tell the difference or not?
I could tell a little, yeah.
Okay. Good. So this is how we figure out puzzles. You subtract something and then everything else gets smaller. And when you add something, everything else relatively gets bigger. So there's a plus and minuses going on all over the place, and it gets really, really difficult. For those of you who are like the G Nashi, the back hole in the high octave, you only have this little short flute, and when you want this big bore, which the low tones are really nice, well, what happens is a high octave doesn't work very well. But for sure, check out, you know, if both holes open or both holes closed or just the second hole or just the first hole. And be sure you work on, even for your 1/8s that are putty filled, be sure you check to see which one works the best. And if you think about it, if you press water down into here, any of these points, for instance, the choke point, and actually right in here, are 2 points where you could make this slightly smaller, and it might not ruin some other things. You wouldn't want to mess with this too much, and the other thing you can do is also make that hole a little bit bigger. The high octave with a big bore in that very short flute, it's just seriously difficult. And I have a 3.2, it's almost 3.25, it's almost a meter long. And the worst note is that one. But I just opened up the flute a little bit, and I just I don't sit on it. And if I have to play that a long time, I use the go no hi or the P fingering for that note. Just because everything else is working so nice. And that particular flute, I didn't add anything to it, so it's completely bamboo, nothing except for urushi. I added a thin coat. So I specifically didn't want to do anything. In fact, I went all day seeing how I can improve it, pushing around little pieces of paper, literally about 8 hours, about like this, trying to see, well, isn't there someplace I can improve it? And the answer was no, it's good like it was. And I was thankful for that. Yeah.
If something as small as this can make that big a difference, if you've been playing for a while, does the spit build up on the inside of the
Yes,
instrument and
definitely.
affect the sound?
So even if you're on stage and it's a little bit embarrassing, definitely clean out your flute because you can see if that much is affecting it, a drop of water also affects it. So definitely clean your flute if you play a number of pieces and you're doing that. Sometimes I make a joke and I say, you know, it's really easy to do this. You know, other people have to do a swab cloth and stuff. Wouldn't it be great if we could do it, you know, ourselves? You know, make a stupid joke like that. But nevertheless, you should clean it out because everything affects it. Yeah. And as you've been playing for a while, you know, dust and stuff accumulates, not only at the Nakatsuki point, but on the insides of the holes. All of that, just take a little brush or some, a towel and just wipe it so that it's clean. And everything affects everything.
I use Q-tips.
Q-tips, there it is. And Mr. Monty Levinson, Willits, California, if you know him, he actually makes a little tiny sponge where you can clean the holes of your flute. Yeah, yeah. And that's a clever idea. He's the only guy that I know that even thought of doing that. Yeah.
So would you cut holes to pitch and then tune to make that pitch
Okay.
where you want it?
Yeah. So you should be close, but I always open the hole a little bit low because I definitely want to not have a hole that looks like this. And you would be incredibly surprised. In fact, I meant to bring a copy. On my 1.8, I measured as accurately as I could the whole thing, the inside. And what you get is a bore that looks like this. It's just amazing. It's amazing that I can't get any of these to work. Maybe people don't like red. The bore looks like this, and then it goes like this. There's all these mesas. Literally, it is this bad or this good or whatever. The inside of the bore, it looks like that. I mean, it's hard to visualize that. It's this incredibly huge dent. So all of the holes make an incredible difference. And then even more so when you want to have a better sound by doing this. I had a friend who was disappointed in a $15,000 bassoon. And he said, what I was telling him about the research I was doing, and he said, an instrument repairman came through, and all he did was just took this little tiny file and he knocked off all of the corners. And he said, and finally my $15,000 bassoon played like a $15,000 bassoon. He said it was terrible before the guy came in and did that. Why didn't the company do that to begin with? And that's what I asked too about shakuhachi makers. So, because I want to undercut the holes, and this also is kind of a little tiny Helmholtz resonator. When a hole is like this, the air goes in and actually gets squeezed a little bit, and then will pop back. So it helps set up the vibration. So I believe that it is actually helpful. And the acoustics that I understand about the shakuhachi, I used to invent a bamboo drum, which you can see in the back here. And especially, you know, the holes, if they're straight, this is all bamboo with bamboo heads, fully vegetarian drum that I invented. And the holes are, if they're straight or if they're in cut, the bass tones are totally different. You hear this boom. It resonates really nice. And when it's straight, it's more like, maybe not quite that bad, but pretty close. The way I got it to do that is by making it leak here a little bit. But, you know, this is really far out. And I messed up my shoulder, but maybe David would demonstrate it. He's going to perform with me in the jazz thing on the forum tomorrow. And he's going to join the jazz group. So if you have a chance, please come see it. We of the jazz people kind of got shuttled to the lower 40 kind of thing. And I believe there are workshops going on and stuff that you know, they didn't do that with any of the other musicians, but Zach and I are sort of commiserating together. What? You don't want to listen to jazz, guys? You know? But anyway, David, maybe I'll just demonstrate.
Yeah.
Yeah, why don't you? It's better. You would think that a shoulder wouldn't be too bad, but maybe I'll play it. I have a small one that goes in harmony. So the acoustics for this and the ideas for that are also totally related to this, because when you hit that, it's the air column. Give it one last. Okay, so this is the sound of bamboo, because this is only bamboo head and bamboo chamber. So this is also the sound of this piece of bamboo, but it's the chamber on the inside that's giving it the unique shakuhachi sound. So if I used wood, you would get the same sound, but the bamboo heads are different than the wood heads. I know, because I changed it. And in fact, it's a trade secret, but the reason I was able to invent this, we were talking about, you know, vibrations of the material is not happening. It's because this head is thick enough that it doesn't vibrate when you do the bass tones. When the head becomes thinner, it disturbs the resonance of the bass. So, thanks to the bamboo, the drum was invented. Okay, we have very short time for, I really didn't go into things half as much as I wanted to, but it gives you an idea, and I hope with the hands-on part where you played, that maybe you could tell the difference in the way your flute played. That's what I'm doing. You send me your flutes, say, oh, what do I do? The roll is terrible. Well, I go in and I look, and it's not only just the roll point, but it might be right next to it. Or if it looks like the back hole is really thick, that might be a hint that it's deeper than it needed to be. That kind of thing. And so then I work there. So you have to expand your mind, but these are the principles. Yeah.
So once you identify with the paper where you want to work, you build up and take away.
You're right.
You have special like long
Yes.
gouges.
Yeah. Yeah. Well, I have sanders and files, a rat tail file, but it's only this long. Then I go in there and I get it like that. Then I take sandpaper and do the same thing. Okay. And so taking out is like that. The only thing is adding is you can sort of test run it, you know. So it's a little dangerous, but what I do, I put